Okay, greetings. So we are still on our topic, matter. And we are going to look at the mole as a concept, the mole concept. Right, so that is chemistry designed for non-science students, right? We do almost the same thing, right? The difficulty of the question is the only difference. Now, what is a mole? So we say the mole is the amount of substance which contains as many elementary particles or entities as there are in 12 grams of carbon 12, right? Or as there are atoms in 12 grams of carbon 12. As there are atoms in 12 grams of carbon 12. What do we mean by that? It contains as many elementary particles or entities as you can see atoms in 12 grams of carbon 12. Meaning, when you weigh carbon 12, not carbon 14 or carbon 13, a carbon with a mass number of 12, you just weigh 12 grams of it. When you open it, the number of entities or the particles you see inside is equivalent to a mole. That's all. So when you open 12 grams of carbon 12, and you see 2 or 6 SI books inside, it means a mole also contains 6 SI books. Are you okay? That is it. The symbol for the mole is moen. And the units of this word mole is just mole. But the symbol for this mole is MOL. It's just by coincidence, right? The SI unit for mass is kilogram. But the symbol for kilogram is kg. Oh? But here, our symbol for mole is MOL. So when you see answers with this, the symbols are used. When you see answers spelled this way, then the word has been spelled. Are you okay? Molar mass is defined as the mass of 1 mole of a substance. So your mass, my mass, your mass put together forms what we call a molar mass. And the unit is given by gram per mole. Gram per mole. But the mass we use here is measured in grams, okay? So there's a relationship between number of moles mass and molar mass. Avogadro's constant is the number of entities containing 1 mole of a substance. When you just break 1 mole of a substance, just like this, right? The number of entities you see here is equivalent to what we call the Avogadro's constant. It is 6.023 times 10 to the power 23 entities per mole. Relationship between number of entities, number of moles, and Avogadro. So when do we use this capital N? When they tell you find the number of atoms, they are talking about these entities. Number of molecules, number of ions, number of electrons. But when you are told number of moles, they are just talking about a small n. Are you okay? So there's capital, there's small n. Don't mix them up, right? So, now application time. Over here. So find the molar masses of the following. I can have H2S. I can have here H2SO4. So H1 sulfur 32, oxygen 16. So when I'm giving this work, what do I do? So you have been given something like this. What do you do? Okay, so when I finish, you take it. The molar mass is defined as the mass of 1 mole of a substance. And ones you see here in parentheses here are the masses of the different atoms you see in that particular compound. Are you okay? So when you ask me to find the molar mass, I just write molar mass of this is given by, you see, the mass of hydrogen is 1. But hydrogen appears 2 times. You see, that's why I say 2 times 1. That of what? Sulfur is what? 32. So what is the answer here? 34 gram per mole. I have found the molar mass of this. Are you okay? Look at the next one. Now the molar mass of tetraoxosulfate 6 acid, sulfuric acid, or H2SO4. Hydrogen appeared 2 times. You see that? That's what 2 times the mass, right? Sulfur appeared just 1. Oxygen is 60, but it appeared 4 times, right? That's why we are saying 4 times this. If not, it should be 16 plus 16 plus 16 plus 16. 4 times. It is 2 plus 32 plus what? 64. 98 gram per mole. It's the same thing. When you bring this minus 1, that is the head. When you remove this and you bring the slash, then the pen will not come again, right? So that is how to find molar mass of substances, right?